Okay guys, this is going to be a supplement to lesson 4.6. This is a short little lesson on solving absolute value equations and also absolute value inequalities. This is probably something you have seen before in the past, and so I'm hoping this video will be just a nice little review, and after you're done going through the examples I show you on this video, you're going to practice a little bit independently. So when we're solving absolute value, I think the most important thing to note is that there is no function that undoes absolute value. You know, with x squared, we know that square root undoes the x squared function. And with the square root, we know that x squared undoes the square root function. There is a function that is the opposite or undoes the given function we start with. That's not the case with absolute values, and so we have to approach it slightly differently because we know the absolute value can yield two answers. Because when you absolute value a number, you normally get always a positive answer. So I can absolute value a positive number and get a positive, but I can also absolute value a negative number and get a positive as well. So when you look at my first example up here, I can have the absolute value of 3 also equaling 3, but I can have the absolute value of negative 3 equaling 3 as well. Therefore, there are two cases that are going to make this equation true. So to solve for an absolute value, you are going to break up what's inside the absolute value into different cases. Your first case will be when x minus 4 equals a positive 3. Your second case will be x minus 4 equals a negative 3. This is really what undoes the absolute value, setting up the two separate cases. And so from here, we're going to solve each equation out separately. And my first solution will be x equals 7. It'll be the same process. I'll be adding 4 to both sides just like I did on the left, except this time I'm going to get a different answer, x equals 1. And that's it. That's how you are going to undo an absolute value. I can add additional operations as well to the absolute value, either inside or outside the absolute values, and I'll show you some different variations on those problems. Please write down the next example. Absolute value of 2x minus 4 equals 14. Again, there is no function that's going to cancel out the absolute value, so we're going to immediately go to two cases. Case 1, 2x minus 4 equals positive 14. Case 2, 2x minus 4 equals negative 14. Because when I absolute value a positive 14, I will get 14. But when I absolute value a negative 14, I will also get a 14. Therefore, there will be two solutions. Same process on both sides. I'm going to add 4, and 2x equals 18. Divide by 2, and x equals 9 is your first solution. Your second solution, once again, add 4, and 2x equals negative 10. Divide by 2, and x equals negative 5. Both of these values of x will satisfy the original equation given. You can always plug these back into the original problem for x, and both of them should yield a result of 14. Your next example, please write down 2 times the absolute value of 3x minus 5 minus 6 equals 24. You could be tempted at this point to set up two cases for plus and minus 24. That would actually, though, be incorrect. You need to first isolate the absolute value before you can set up your two different cases. So to start this problem out, you are going to need to add 6 to both sides. and 2 times the absolute value of 3x minus 5 is going to equal 30. You still have a 2 in front of the absolute value, so we're going to undo that times 2 by dividing by 2 on both sides. And the absolute value of 3x minus 5 is going to equal 15. Now you have the absolute value isolated, and now you can go ahead and proceed with your two cases. The biggest mistake I've seen in the past are students putting a plus and minus on the 24 without solving for the absolute value first. Our first case will be 3x minus 5 equals positive 15, and 3x minus 5 equals negative 15. We're going to add 5 on the first equation of both sides, and 3x equals 20. And then, of course, divide by 3 on both sides, and x will just equal 20 thirds. First solution. Second solution, add 5 once again. You see these steps repeat. It's going to be the exact same setup. 3x equals negative 10. Divide by 3 on both sides, and x equals negative 10 thirds. Second solution. Again, what was the key I wanted you to get from this problem? That sometimes you have to isolate the absolute value before you undo the absolute value with your two different cases. Next example. Take a moment to write down negative 3 times absolute value of x plus 5 plus 12 equals 6. Again, our goal before we could do our two cases is to first isolate the absolute value. So we're going to accomplish that by subtracting 12 for both sides. And negative 3 times the absolute value of x plus 5 equals negative 6. We're going to divide by negative 3 on both sides, divide by negative 3 on both sides, and the absolute value of x plus 5 equals positive 2. Now you're ready for your two cases. X plus 5 equals 2. X plus 5 equals negative 2. Subtract 5. X equals negative 3, first solution. Subtract 5. X equals negative 7, second solution. Before I move on to the next example, I want you to consider one variation on this example here. I'm going to clear this work off, and I want you to consider what would happen if there was no negative here. If instead we had 3 times the absolute value of x plus 5 plus 12 equals 6. So really the only thing I did was I took this negative and I got rid of it. What would happen here? We would still isolate the absolute value by subtracting 12 from both sides. And we would get negative 6 once again. And we're going to divide by 3. But this time, if you notice, when you divide by 3, we're going to have x plus 5 equals negative 2. And this should set off some type of alarm for you. There is no way that this statement can possibly ever be true. Because when you absolute value a number, you cannot get a negative number as a result. This negative right here makes this problem not solvable. Therefore, we say there is no solution. Again, the reason why, you can never have an absolute value set equal to a negative numbers. I'll summarize that. The absolute value function can never equal a negative number. If that's the case, you will not be able to solve. If you recall, the original problem had the negative, and when I go ahead and put the negative back in again, the negatives end up canceling and I get the positive 2, which is what we did before. However, that was not the case with the second example I gave you, or variation on this problem rather. Please be aware of this situation. I would now like to show you how you're going to approach a problem if we change the equal sign to an inequality sign. If this is the case, you do a different approach depending on which inequality sign is given in the problem. This is a less than problem. When you see a less than symbol, you're going to create what I like to call the less than sandwich. With an inequality, you now have a lot more opportunity for several more numbers that are going to make this true. It's no longer going to be a two-solution problem. It's going to be a range of values that make this true. The less than sandwich is set up once you get the absolute value alone. Right now, the absolute value isn't alone. Right now, you're dividing the absolute value by 3. So to undo that, I am going to multiply by 3 on both sides in order to cancel out that division by 3. These 3's cancel, and then the absolute value of 2x minus 6 is less than 30. Here's how we set up the sandwich. You're going to focus in on this 30 and the fact that the 30 can, again, be plus or minus. On the lower half of the sandwich, you're going to put a negative 30, a less than symbol. Whatever is inside the inequality is going to go in the middle of the sandwich, a less than symbol, and then the positive value. This is called a compound inequality, and your goal is to solve for x in the middle. You'll be doing operations to both this part, and this part. You're going to proceed as if there was just one symbol here and you're trying to get x alone. Your first step is going to be to add 6 to cancel out this 6. But when you add 6 to the middle, you need to balance by adding 6 to the upper bound and to the lower bound. Therefore, negative 30 plus 6 gives you negative 24, which is less than 2x, which is less than 36. You are going to divide by 2 to get x alone, and my final result is going to be negative 12 is less than x, which is less than 18. Therefore, anything in between negative 12 and 18 will make this original inequality true. There's more than just two solutions. There are several solutions. This, once again, is called the less than sandwich, and you will use this process every time you see in a problem a less than symbol. I do want to mention something you may recall from solving inequalities out before. Here we divided by positives 2's. But if we would divide by a negative in an inequality, you would have to switch the symbol. So if dividing by a negative number, you will switch the symbols. And that's something you should remember from 8th grade math. The final problem I would like to review is what happens if we have a greater than symbol. These problems are what I like to call the greater or problems. I know I'm spelling greater a little differently, okay, but I'm emphasizing the or because you're going to create an or statement after you solve for the absolute value. Your first step, of course, is going to have to be to get rid of this minus 5, and we're going to add 5 to both sides. That's good because we know that we couldn't have this equal to a negative number. And so that negative 1 becomes a positive 4. With the greater than problem, you're going to set up two cases. Case 1 is pretty simple. You are simply going to rewrite the inside of the absolute value, keep the sign, and keep the number to the right of the sign. This is case 1. Or case 2 could occur as well. For case 2, we are going to copy what we have inside the absolute value. We are going to switch the sign that we started with originally. And we're also going to change the sign on 4. Notice how case 2 differs from case 1. Case 1 is pretty simple. All you have to do is rewrite the problem without the absolute values. For case 2, though, you are going to have to rewrite what's inside the absolute value, flip the sign because we're introducing a negative on the 4 to do both of our cases. And anytime you ever introduce a negative in an equality problem, we know that we're going to have to flip a sign. Then you're going to solve out both cases. These are easy problems to solve once you get the setup completed. First step, add 9 to both sides, and negative x is greater than or equal to 13. To get x alone, we're going to divide by negative 1 on both sides. But we notice that we're dividing by a negative, and I told you earlier that every time you divide by a negative, you must flip around the sign, and x is less than or equal to negative 13 is half of your solution. Or we will now solve out the second part. I'm going to add 9 to both sides, and negative x is less than or equal to 5. Divide by negative 1, and again, we're dividing by a negative on both sides, so therefore, we are going to have to switch the signs. And we get the following results. This OR statement combined has all of the solutions that satisfy the original absolute value inequality. Either x is less than or equal to negative 13, or x is greater than or equal to negative 5. In this case, there can be nothing in between that's going to satisfy this particular equation. For instance, negative 10 will not work in this particular absolute value inequality. You will get a statement that is not true. If you pick any x in these ranges and plug it into the original absolute value inequality, the inequality should hold true. Once again, this was a greater than problem. Anytime you ever see a greater than problem, it's going to be a greater or. And you will divide up into your two different cases, case 1 and case 2. Make sure to include your or because your solution will be an or statement. This is different than what we just did on the previous problem. This was a less than problem. We created the less than sandwich by starting with the negative result and then the positive result using less than symbols and then sandwiching what is inside the absolute value for our problem here. And that is how you solve absolute value equations with an equal sign and absolute value equations with an inequality. You will now have some time to complete some practice problems on your own. See you tomorrow.